So it's another question about prime factorization. Instead, it's about 54. So let's list out all the factors for 54 first. Okay, let's list out all the pairs of factors. Okay, so we have 54 here. Well, first of all, we have 1 and 54, which doesn't really help because it's redundant to us. We have 2 and 27. Do we have a 3? I do believe we have a 3 here. I think it's 3 and 18. Do we have a 4? No, we don't have a 4, and I think we have a 6. We don't have a 5, so it's 6 and 9. I think that's it. And after that, we revert back. 14. No. Okay. So these are all the pairs of factors. So I'm going to write this all down. Okay. So I'm going to exclude 1 and 54, but we have 2 and 27, 3 and 18, and 6 and 9. Okay. Let's consider the first one, right? So what are our prime factors here? We have 2, but 27 is not a prime factor. But we can further break that down to be 2 times 3 times 9. So we're getting closer, right? So now we see that we have 2 prime factors, which is 2 and 3, but we still have 9, which is still divisible by 3. So we have 2 times 3 times 3 times 3. And now we have all prime factors here. So this is the prime factorization of 54. Okay, let's check out 3 and 18 here, okay? So we only have 1 prime factor, but 18 is not a prime factor, right? It's not a prime number. So we can further break this down to be 6 and 3, sure, right? So we have 3 and 3, which are primes, numbers, but we still have 6, which is not a prime number, so we have to keep going. So 6 is divisible by 2, so we can do 2 times 3, so it's 2 times 3 times 3 times 3. Cool. Now you guys notice a pattern here, right? The prime factorization is always going to be the same. Let's try with 6 and 9. So here we don't have any prime numbers here, right? We have 6, which is divisible by 3, which is 3 times 2. And we also have 9, which is divisible by 3, which is 3 times 3. And would you look at that, we also have the same prime numbers for the factorization. And that brings us to an important conclusion. Every number, or not every number, but a number that has factors will always have the same prime factorization. And it's the most reducible you can get to the factors of a number. Okay? You cannot reduce this anymore because you can only divide by the number itself or by 1. And dividing by 1 will produce the same number. Okay? So yeah, so the prime factorization is the most reducible factors of a number. Okay? So the junior tutor, they used the 6 and 9 pairing to find our prime factorization, and then they changed the form to be 3 cubed times 2, which is perfectly valid. So this solution is correct. Good work. All right, let's move on to question number 7.